Hey guys, and welcome to this video on the Python programming language and machine learning. So in this video, we are going to create a simple logistic regression program to classify iris species. And right now I'm on a website called colab.research.google.com. And the reason why I'm on this website is because it makes it really easy to get started with programming in Python. So you don't have to actually install Python programming language onto your computer or machine. You could just go here to this URL on your web browser and log into your Google account. So yes, you do need a Google account, and yes, you do need a web browser. I'll be sure to put this link in the description below so you guys can get it as well and go to this website and start programming in Python. So let's go ahead and get started. First thing we're going to do is click File here, and then I'm going to click New Python 3 Notebook. And then what you're going to see is that it opens up a new tab, and it's going to give us a cell to start programming in. So now it's ready. So I'm going to go ahead and just show you guys kind of how it works a little bit. So we're just going to print this is a test in the cell, and I'm going to go over here to the left and click this play button, and then we'll see that it prints this is a test to the screen right here. And now if I go to the left again, I can exit out of this, and what we can do is we can continue programming in this cell and write our whole Python program, or what we can do is break it up into different cells. So to do that, we just go up here to code after clicking within that cell, and now it adds another cell. And so I can print another statement here and say this is another test, and we can run this cell individually. So I just click here to the left of that cell, and you see that it prints out this is another test. All right, so suppose I want to run both of these print statements. I can just click runtime and click run all, and then it'll run both of the statements. All right, so I'm done with this second cell here. So I'm going to click in here, and I'm going to go to these three dots, and then I'm going to delete the cell. So let's go ahead and get started with our program, our logistic regression program to classify iris species. All right, so first thing I'm going to do is give a description of what the program does. Okay, so I'm going to say this is and I'll make it all capitals, this is a simple logistic regression program to classify iris species. Okay. All right, so first thing that we need to do is import the dependencies. Okay, and we are going to import matplotlib or lib, and we're going to get pyplot, and we're going to call it plt. So we're going to import matplotlib.pyplot as plt. Okay. Next, we're going to import seaborn as SNS, and this is where we're going to get our iris dataset from. And now we're going to also import our machine learning library called sklearn. And I want to get the linear model. So linear model. And from there, we're going to get our logistic regression method or function. Okay, so I misspelled model here. There we go. All right, also from sklearn, I want to get some metrics. And so we are going to import the classification report method. And from sklearn metrics, I also want to get the accuracy score method or function. And then last but not least, from sklearn model selection, I want to import train underscore test underscore split. So I'm going to get that function there to split our data into training sets and testing sets. So let me go ahead and run this. Look like we have a few errors. Let me see logistic regression. Logistic, it should be a capital R here. So if I run this, all right, now the error is gone and we're good to go, and we have imported our dependencies. So let's go ahead and add another cell, And here we're going to load the data set. So I'm going to create a variable called data and set it equal to sns.load. So we're using the Seaborn load method or function, and we tell it to load the iris data set. And let's take a look at this data. So I'm just going to say data.head. And if I run this, let's see, Seaborn has no attribute called load, okay, because it's called load underscore data set. So that's the actual method there. So let's run this again. And now we can see the data set, the first 5 rows of the data being printed to the screen. Okay, so I'm going to go ahead and add a new cell. And here we're going to prepare the training set. So we're going to have our independent set. We're going to call it X. And so X is going to be equal to feature values. And so we're going to get all of the columns except the last column. Okay, and to do this, I just simply say X equals data.ilock. And of course, X is the variable that I just created. And we want to get all of the rows except for the last one. So except for the last row there. I mean, except for the last column. So we want to get all the rows except for the last column. Make sure I state that very clearly. All right. Next, we're going to create our Y data set or our dependent data set. So this will contain the target values, and we only want the last column of the data frame. So I'm going to create my variable called Y and set it equal to data.ilock, and we just get all of the rows and just the last column. So although they look very similar, notice that this here has a colon and then -1, and here I don't have any colon at all. So I'm going to go ahead and run this, make sure there are no issues, and it doesn't seem to be. So let's print and take a look at the data sets that we just created. So I'm going to print X, and so we can see our X data set contains those 4 features or 4 columns from the original data set. And let's go ahead and print Y, and it should have only the last column, species. And as we can see here, it only contains the last column that has the data for species. Okay, so I'm going to go ahead and get rid of that print statement. Just run this again, and let's go ahead and add a new cell. Okay, and let's go ahead and plot this data. So we're going to plot the relation of each feature with each species. And to do that, I'm going to use matplotlib or lib. And so we called it PLT. And I'm going to give this plot a label on the x-axis. So we're going to say x label. And I'm going to call this features. And then I'm going to do basically the same for the y-axis. So plt.y label. But this time it's going to be called species. All right. Now let's give it some data. So I'm going to create plt x variable. So that stands for plot x. And the data, we're going to get the data from our data set. So data.loc. And what I want to get is all of the rows from the sepal underscore length column. And to make sure I'm spelling that right, I'm just going to go up here and I'm going to do Control C to copy sepal length. And I'm going to go here and paste it using Control V. All right, that's just to make sure I'm not misspelling anything. And then I'm going to do the same thing for Y. So for a data set for Y, call it PLT capital Y and set it equal to data.loc. And I want all of the rows from our target column. So that's the column called species. And I'm pretty sure I'm spelling that correctly. And let's go ahead and just run this. Okay, excellent. All right, so now we need to tell it what type of plot we want. So we want a scatter plot. So we just say plt.scatter, and we use that function or method there. And then we need to input some data. So we're going to input the X data set, and we're going to input the Y data sets. And then I need to give it a color. Well, I don't need to. This is actually optional. So I'm still going to give it a color, and we're going to give it the color blue. And then I'm going to give it a label as well. And it's going to be called sepal underscore length. And what I'm going to do is I'm just going to copy this right here using Control C and paste it here using Control V, just to make sure I'm not misspelling anything. Okay. And what we want to do, since we want to do it for each feature, we're going to have to do this 3 more times. So I'm just going to take this whole thing, and I'm going to do Control C to copy it, and I'm going to paste it 3 times using Control V. So 1, 2, 3. Okay. And now what we're going to do is just change it up a little bit. So I'm going to grab the other column names. So sepal width using Control C, come down here and paste that here and here. And then we're going to change the color to something like green. And then we'll do the same thing for the next column. Go up here, Control C to get the column, and come over here and Control V to paste it there and there. And then we're going to change the color again. So this time I'm going to change it to red. And last but not least is the petal width. Control C, and here, okay, here, Control V, and here, Control V, and then we're going to change this color to black. All right, and then let's give it a legend. So plt.legend, so we know, what's going on in the plot, so we know what the different points are. And then we want to show our graph, so we just say plt.show, and let's go ahead and run this. Okay, and now we get a nice graph showing this data. So let's see here. This is giving us species, species, species. That is not what I want. So let's see what's going on here. Sepal length, PLT red. I want the labels to be sepal length, sepal width, petal length, and petal width. So let's run this again. Let me see what's going on. Okay. All right. So it looks like I'm missing something here. So what am I missing? What I'm missing is this capital L. It's not supposed to be capital, it's supposed to be lowercase. And so it doesn't know what capital L label is. And so that's why those labels are species. So let's go ahead and run this. Yes, there we go. So now we get the sepal length, sepal width, petal length, and petal width. And it still looks kind of funky because now it's covering some of the graph. So if I say LOC equals 4, and let's see, change the size to 8, maybe this will make it look a little bit better. And it does. All right, so this is our graph. Perfect. All right, so now let's go ahead and go to the next cell by adding a new cell. And here we're going to split the data into 80% training and 20% testing. All right, and I'm going to create some variables. One's going to be called xtrain, the other one's going to be called xtest. The next one will be called ytrain, and then ytest. All right, and we're going to use that function or method called train test split. and we have to give it a few parameters. So we have to give it our dependent, our independent data set, and then our dependent data set. And then we need to tell it the test size and set it equal to 20%. So that's equal to 0.2. And this is optional, is the random state. So you don't have to put that if you don't want to. I'm just going to put 42 here. Um, don't worry about random state too much. If you want to read more about what random state is, it kind of randomizes our data and keeps the it keeps the state of it. So if you were to change this number, it would be, of course, a different state. But you can read more about it online on the sklearn website, where they have good documentation on what this method does. So let's go ahead and run this. Okay, so it looks like there's no problem. And let's add a new cell. Okay, so here we're going to train the model. So I'm going to create a variable called model and set it equal to our logistic regression function or method. And then let's go ahead and train the model. So we just say model.fit. So fit is another word for training. And we're going to train it on the xtrain data set and on the ytrain data set. Okay, so here, just let you know in the comment, we're training the model. Okay, so let's go ahead and run that. Excellent. This is not an error message. So let's see what we want to do now. Maybe we want to test the model. So I'll go ahead and create a new cell. And here I'm going to put test the model. All right, and I'm going to create a variable called predictions and set it equal to model.predict x underscore test. And so now we're making predictions based off of the testing data set that we created up here. So if I run this, okay, like everything's good. And let's take a look at the predictions. Okay, so these are the predictions from the testing data set. And let's take a look at the actual values. So we're going to print y underscore test. Okay. And so this is the y. This is the target variables from our x test data set. So let's see. We see that the prediction thought the first one was versicolor, and it is. Next, it thought the next one was setosa, and it is. Okay, then it thought the next one was virginica, and it is. So it's doing pretty good. Versicolor, and the next one is versicolor, and so on and so forth. So it looks like our model's doing pretty well. I am going to use a metric to kind of determine this a little bit more mathematically. So to do that, we can use something called a classification report. So I'm just going to get rid of that. And we're going to do something called checking the precision. We're going to check the recall, the F1 score. And all right, that should be it. So to do that, just say print, and then we're going to use the function called classification underscore report, and we're going to put in the testing data, so y test, and then we're going to put in the data, or our predictions actually. We're going to put in our predictions, so that's the data that we predicted, right? And let's go ahead and run this. Okay, and now we get back a metric of how accurate our model is, and this model is very accurate. Looks like it's 100% accurate. The best possible score for these values are 1.0. and that's what we're getting and seeing here. So that's very interesting, and that actually kind of makes me question a few things, but that's good that we did get this accuracy. So that's actually very, very good that we got this accuracy. So our model's pretty good. I mean, that we got this precision, this recall, and this F1 score. And if you guys don't know what that mean, what those columns mean, basically a precision is the true positives divided by the true positive plus the false positives. Um, Accuracy is basically the true positive plus the true negative divided by the true positive plus the true negative plus the false positive plus the false negative. And let me see here. Precision is basically the true positive divided by the true positive plus the false positive. So where am I getting all this from? Well, if you can get all this information from looking at something called a confusion matrix, and you can just kind of look that up on Wikipedia or something, or maybe online uh, in a math book or something like that, and you can get a better understanding of what those column values really mean. Okay. And last but not least, this is, although it's not really necessary, I'm going to print the accuracy. So I'm just going to say accuracy score. Actually, I'm going to print the accuracy score. And to do that, we just need to give it y test and predictions. And the accuracy score is just going to be 1.0 because we already see that the accuracy score is 1.0 here. All right. So anyways, these are some metrics you can use to test your model. Our model is very, very good. And I hope you guys learned a lot in this video. So please leave any questions you have. Please leave likes and comments. Don't forget to hit that subscribe button and that like button. And if you found this video helpful, please share it. I'll be sure to put the code up online as well on my GitHub and put a link to that in the description below so you guys can check it out, as well as the URL to this website, like I said earlier. Anyways, guys, thank you very much for watching, and I'll see you all in the next video.